So this video is about the traditional scientific method and the issue of reductionism. And the material is supported by a publication from 2019 by Junior Costa and colleagues called A Framework for a Systems Design Approach. And just before I go into the video and the content of the video, it's really useful to know what do I mean by the scientific method. It's something that often gets mentioned, especially people referring to the traditional scientific method. So based on Wikipedia, it is an empirical method for acquiring knowledge that has been referred to while doing science since at least the 17th century. Historically, it was developed through the centuries from the ancient and medieval world. Through empiricism, which is a type of philosophy. And the roots of it goes back to people like the Stoics, like Aristotle, like Ibn Haytham, like Al-Biruni, Roger Bacon, and many others. And it also went through different iterations during the 16th as well as the 17th centuries, during the scientific revolution of this period. And it went through different iterations and development, especially, through the rationalist approach, which was described by René Descartes, and inductivism as well, also, which was brought by Isaac Newton, and also many others like Galileo Galilei and many others, other researchers that and philosophers and thinkers that contributed to it. So the scientific method has traditionally adopted what they call reductionist attitude and analytical thinking to solve and handle complex societal problems. We'll get to reductionism in a second. This scientific method tends to follow specific major steps. Junior Costa and colleagues talked about these steps, and these tend to involve doing analysis by reducing complexity, developing hypotheses, experiments being designed and replicated, results being deduced, and also, lastly, rejecting hypotheses. So now let's go back to the concept of reductionism, especially if we are trying to deal with complex societal problems. Let's explain first what reductionism means to give you an idea of why the traditional scientific method often fail to deal with complex matters. So reductionism sees that deducing explanations, i.e. of an entire system, is valid if you explain phenomena using one level, and that means essential components that make up the system. For this reason, in reductionism, everything can be reduced or disassembled to its essential and independent components. This way of thinking about phenomena then becomes the foundation of how we conduct analysis, which ultimately reduces the behavior of the whole system being analyzed. Because we are ultimately summing the behavior of these essential components to explain this whole system. So when we use the traditional scientific methods, reductionism leads to the following process. We tend to define a problem. We reduce this problem into sub-problems. We then find solutions for each sub-problem, or what they call sub-solutions. And then we average out all sub-solutions to address an entire problem. So do you see here why this could be an issue? If we are dealing with complex, interconnected, interdependent parts, we lose nuance, we lose context, and we lose relationships in that process. Because the whole is more than the sum of its parts, as Aristotle and other philosophers and thinkers like Kurtz, Kafka thought. This fundamental way of thinking is known as holism. In holism, and holism is different than reductionism. It is about putting things together instead of tearing them apart analytically. It approaches problem handling and stakeholder values using methodologies and tools that are associated with systems thinking language. So systems science has been suggesting holism as a way to correct this reductionism, this way of thinking, to understand societal problems. So after these few slides, you might start thinking, do you use holism or reductionism when you deal with phenomena or societal problems? Well, the idea is to use both ways of thinking, and systems thinking should complement the existing dominant traditional scientific method that has been established for a long time. Traditional scientific method can't address our problems alone. It is ineffective in handling those complex societal issues because of the lack of uncertainty of the knowledge required to address the issue, and also the lack of understanding of the characteristics of the system in place. This means that any proposed solutions may lead to new issues down the line or in the future that you're trying to solve, that you're trying to study perhaps. For example, let's give you an example. You may use an energy efficient transport method because you want to address the climate crisis. But this may lead to side effects such as energy consumption, increase in the kilometers that you're traveling and using, increase in the number of cars available, of the cars being created, being sold, and being supplied in the market, and many other consequences that defeat the purpose of going with a technical improvement to have you travel so you can address the climate crisis. So you can see from this only one example how reductionism fails to really or could create other problems in the future and doesn't perhaps address and solve the issue at hand. If we use that way of thinking, perhaps that traditional way of thinking and that reductionism of thought. So hopefully this video gave you an insight into the relationship between the traditional scientific method and the issue of reductionism, that way of thinking about how to analyze in terms of, and from the point of view of analyzing your phenomena, your topic, your problem, and this is all taken from the point of view of systems thinking.